As a refresher, let's look at how we ended the first part of this video series. We looked at a control loop where a differential pressure transmitter is connected to measure an open vessel level. The high pressure port is connected at the 0 inches point, and the low pressure port is vented to atmosphere. We said that pressure in inches of water is equal to the relative density of the liquid multiplied by the height of the surface of the liquid in inches. We talked about converting the resulting inches of water pressure value into any pressure scale you need, such as psi, kilopascal, or bar. Okay, that works just fine if the liquid in the vessel is water. What if the liquid stored in the vessel is not water and doesn't have a relative density of 1? The relative density of most liquids will change with temperature. For the sake of simplicity, we will ignore the effective temperature for now. Interestingly, when the vessel is at full, at 200 inches, the pressure developed is much lower because the liquid has a low relative density. That is a critical consideration when calibrating the differential pressure transmitter. Let's assume the differential pressure transmitter is calibrated to produce 4 to 20 milliamps for a liquid level range of 0 inches to 200 inches. So far, we've only considered open vessels. Let's move on to the level measurement of closed vessels. The major difference between open and closed vessel level measurement is the fact that we need to consider the pressure in the vapor above the liquid in the closed vessel. This vapor pressure exerts a force on the surface of the liquid. We can compensate for the vapor pressure by connecting the low pressure side of the differential pressure transmitter to the top of the vessel through a pipe referred to as a reference leg. The reference leg may be dry or filled with liquid. If the reference leg is dry, it is commonly referred to as a dry leg, and if the leg is filled, it is commonly referred to as a wet leg. In a dry leg system, the vapor pressure is applied to the high pressure and the low pressure sides of the differential pressure transmitter. The same pressure applied on each side basically cancels each other out. Sometimes the reference leg needs to be filled with a fluid. This leg is now referred to as a wet leg. There are many reasons for a wet leg, such as avoiding the error in measurement caused by vapor condensate in the reference leg. Let's look at an example of a wet leg system. The differential pressure, as always, will be high pressure minus low pressure. But the resulting differential pressure is not easy to predict because the liquid in the vessel is usually not the same as the liquid in the wet leg. Let's review what we've discussed. Liquid relative density and temperature have a significant effect on differential pressure transmitter level measurements. A reference leg is used to compensate for vapor pressure in closed vessels. A dry reference leg is called a dry leg. A wet leg is a reference leg filled with a liquid different from that in the vessel.
Subscribe now and press the bell icon. Never miss an update.